So it was the Oersted discovery. Then the Biot-Savart's law. Biot-Savart's law. What was the Biot-Savart's law? Biot-Savart was the another scientist, right? According to him, he performed the many experiment. But Oersted discovered that due to flowing the current in the wire, the magnetic field is produced. But how much magnetic field is produced and what is the direction, right? It is told about by the Biot-Savart. So according to him, if the current is flowing I, and if you take the elemental portion dl and you choose a point P in the space whose position vector is r, with right from this elemental vector, and this is the theta. So the elemental magnetic field is produced due to this elemental portion. So according to Biot-Savart's law, the magnitude of this element magnetic field produced is proportional to current flowing in the wire, right? It proportional to the length of the wire, is proportional to the sine theta, where theta is the angle between dl and r vector, and inversely proportional to the r square. So by experiment he found this, right? So dv is proportional to I dl sine theta upon r square, right? If proportionality constant is removed, so mu naught upon 4 pi I dl sine theta upon r square. So this is the elemental magnetic field, right? Due to the elemental portion, if the current I is flowing in it. Is it clear or not, you tell? Right. B is the dv is the elemental magnetic field, right? Magnetic field, or sometime it is called magnetic induction or magnetic induction, right, is a vector quantity. Magnetic induction is a vector quantity, and SI unit is Tesla. Are you getting or not? SI unit is Tesla. Is it clear? This constant mu naught upon 4 pi is equal to 10 to the power minus 7. And mu naught upon 4 pi, what will be its unit? This is Tesla, mu naught upon 4 pi. This is in ampere, in meter. Sin theta has no unit, and this is the meter square. So what will be the unit of mu naught upon 4 pi? Tesla meter upon ampere. Tesla meter upon ampere is the unit of mu naught upon 4 pi, where mu naught is equal to 4 pi into 10 to the power minus 7. Tesla meter upon ampere. It is called permeability. Permeability of free space. Free space or vacuum, you can say, right? Copy this. So one more thing, the CGS unit you can also write, right? CGS unit of B is Gauss, right? And what is the relation between the Tesla? 1 Tesla is equal to 10 to the power 4 Gauss. I will explain this. How does it come? All right. That is the thing, right? So this is the CGS unit, right? Listen, one more thing. It may be written in the form of vector, right? Since it is a vector quantity, if you consider this is the dl vector and this is the r vector and this is the theta. So the dl vector, this is the element length vector cross r vector, right? So what is dl cross r? Magnitude dl into r into sine theta. Is it clear or not? If you consider this, the dB is equal to mu naught upon 4 pi I dl sine theta upon r square, right? So here in the numerator and denominator, you multiply by r and it become r cube. Are you getting or not? And this dl r sine theta, the magnitude become mu naught upon 4 pi dl cross r, right, upon r cube. In vector form, it may be written as. Is it clear or not? So I told you it is a vector quantity, So if it is a vector quantity, therefore direction of vector B is along, yes, along dl cross r. Is it clear or not, you tell? Or given by right hand thumb rule. Right hand thumb rule. What is the right hand thumb rule? I will explain this. First, you consider this is the dl cross r. Suppose this is the vector A, this is the vector B, and this is the angle theta. Can you tell me what is the direction of A cross B? A cross B. A cross B is what? Into the board. Into the board. Therefore, this is the dl, this is r. So dl cross r is what? Into the board. So if this is the dl vector, this is the r vector. So the dv vector is into the board, and into the board is represented by cross. Is it clear or not? Yes. Right, like this. If you take the position at this point, suppose on the left side, right, this is the dl, right, dl cross r. This is the dl vector. If you are taking the dl vector this, and the point is in this direction, this is the r. So what is the direction of this? Is the dl vector. This is suppose the alpha. So dl cross r out of the board. So here this side the magnetic field will be out of the board, right, out. So out is represented by dot, fine, and into is represented by cross. So although the direction of db depends upon the direction of dl cross vector, r vector, right, but still there is some another rule which is easier than this, which is called the right hand thumb rule, right. So I will explain this. Copy this first. So what is the right hand thumb rule? Right hand thumb rule, right, right hand thumb rule. So according to this, if this is the current carrying wire, you hold the wire, right, in your right hand, and the thumb represent the direction of the thumb is along the direction of the current, right. Then the curling finger represent the magnetic field. So here the magnetic field is like this. Are you getting or not? Right. Yes. This is the current I, you can say. Fine. Yes. This is the current I. So if the wire is in, the current is in our direction, to curling finger, right. For example, if this is the current carrying wire, so if you take this point, the current is out of the board for this. Yes. And if you choose this point, the current is into the board this side, right. Yes. If you see the from the top, this is the side view, right, this is the side view. If you see the top, from the top, the current is coming out here. This is the current carrying wire is coming out like this, right, like this. So take your right hand, and the magnetic field will be like this. Magnetic field form the closed loop, right, and they form closed. So magnetic field at this point will be in this direction, in this direction, in this direction, in the direction. Since the magnetic field direction is changing, so you can write these are the B1, B2, B3 vector, whatever the magnitude. I am not talking about that, right. Suppose in this case the current is what? Coming out of the board. The current may be downward like this, right. Yes, current is like this. So take your right hand. Suppose this is the current carrying wire. This is the black portion is into the right downward. Take your right hand like this. So and curl your finger, right. So curling finger give the direction of the magnetic field like this, right. So here the magnetic field is out of the board, right? Current is like this, the magnetic field is out of the board, and here it is into the board. Are you getting or not? Right, like this. If you see from the top, right, if you see from the top, the current is going, this cross mean the current is going inwards into the board. This is the dot mean current coming out from the board. So it is going into the board. The direction of the current is, the direction of the magnetic field is like this, into the board. At this point, magnetic field is in this direction, in this way. This is B2. If you consider this is the B3 vector and so on. This is the B4 vector. Are you getting or not? Like this, right? Also, listen one thing. If you consider this is the wire, right? And the infinite current carrying wire it is. So, take your right hand. The current is out of the board, this side into the board. So, the magnetic field always form the closed loop, right? I will explain this in the magnetism, right? So, these are the current, so they form the closed loop like this, right? And like this, they form the closed loop. So, these are the magnetic field loops, and if current is coming into the board, right, downward, so here the magnetic field is out and it is into the board, right? So the current is like this. Are you getting? Like this. The magnetic field direction is like this. Is it clear or not, you tell? Right? This is the downward direction. Copy this. So now we discuss the application of Biot-Savart's law. Applications of Biot-Savart's law, right? Savart's law. What is the application? First, the magnetic induction. Sometimes it is called magnetic field or magnetic induction due to finite, right, current carrying wire. Current carrying wire. All right. Suppose this is the wire. The finite length mean the wire is only of the length from A to B. The current is I, right? This is the perpendicular distance where the magnetic field we have to write. This is the current carrying wire. Magnetic field will be into the board. This side out of the board, right? So look at the figure. If this is the θ1 angle, this is the reference you will take. This is the θ1 and this point B is make angle θ2. Are you getting or not? Right. So here the magnetic field is given by mu naught I upon 4 pi r, right, sine θ1 plus sine θ2. Although there is a derivation, but we are not going to do that. Only you have to, right, remember this formula, right, copy this. So for example, I am giving an example. For example, if the current is wire is 2 ampere, the perpendicular distance is 10 centimeter, right, and you have to find the magnetic field. The direction is into the board such that it is 37 degree, it is 53 degree, right, and this is 10 centimeter, right. This is the point A, this is the point B. Find magnetic field at point P, right. So simple formula you will apply. What is that? Mu naught I upon 4 pi r sine θ1 plus sine θ2. This is the θ1, this is the θ2. Mu naught upon 4 pi value is what you tell? Say 10 to the power minus 1. And the I value is 2 ampere. The perpendicular distance is what? 10 centimeter, 0.1 meter, sine 37 plus sine 53, right. If you simplify this, minus 6, 3 by 5, 4 by 5. minus 6, 7 by 5, right? 1, yes, 14 upon 5, right? 2.8 into 10 to the power minus 6 T for Tesla. Direction is into the board, right? For example, suppose the special cases may be there, right, for infinite wire, infinite current carrying wire. If this is the wire having the current I, it is going to infinite, it is going to infinite. From minus infinity to infinity, the current is carried, the R. Here the magnetic field you have to write. So what is the value of theta 1 and theta 2? Listen, one.
It is 90.
Right. The angle is increasing like this. For infinity, it become 90 degree. For right, this side the theta 1 become 90 degree. Right. So the B is mu naught I upon 4 pi R sin 90 plus sin 90. 1 mu naught I upon 2 pi R. 4 pi R into 2, it become mu naught I upon 2 pi R. And the current is upward direction, the magnetic field this side will be into the board. Right? Copy this. So this is the magnetic field due to the infinite wire. Now we can discuss for semi-infinite wire. Semi-infinite wire. What is that semi-infinite wire? Infinite wire, right? Infinite wire, right? Semi-infinite wire means the wire start from here like this, the A point is this, and it goes to the infinity, right? This is the perpendicular distance R. Here we have to find the magnetic field, right? So the B point reaches what? Where? At the 90 degree.
90.
So the angle theta 2 tending to 90 degree. And what about the A point? What is the theta 1 value? Yes, 0. Why it is 0? Because suppose this is the A point and the theta angle was this, right? Theta 1 this. So if it is reduces, suppose the angle point A become here. So this angle reduces, the point A reaches to this, the angle again reduces. So reducing and point A reach at this point. So the angle theta 1 reduces to 0 and the B reaches to the infinity, it is 90 degree, right? So at this point B naught I upon 4 pi R sine theta 1 plus sine theta 2. So it is 0 plus 1 is equal to 1. So B is equal to mu naught I upon 4 pi R, right? It is into the board due to this configuration. Copy this.
Done, sir.
Okay, so a very good question I am giving you. Suppose this is the finite wire. If this is the A, this is the B. Fine. This is the A and this angle, right? Like this, like this. This perpendicular distance is given. R is 50 centimeter. At this point, you have to find the magnetic field such that this angle is 53 degree. This angle is 60 degree. Current in the wire is 10 ampere. You have to find the magnetic field, right? You have to find the magnetic field at P, right? This is the question. Okay, so here listen one thing. The B point, only the value of theta 1 and theta 2 we have to write, right? Suppose if this is the point A over here, this is the reference line, if it is this side 53, so then it is taken as the plus 53. But due to some reason, if point A, right, reducing here, the point A become, the theta 1 becomes 0, and if you cross this reference line, then the theta become negative. So the point A is above the reference line. The angle theta 1, you have to take the positive this side. So this angle 53 is taken as minus 53. Is it clear or not, you tell?
Yes.
And the B point is as it is, no problem. So this is the reference line. So B is making the 60 degree. So it is in the correct direction. So it is taken as plus 60 degree. Is it correct or not, you tell?
Yes.
So the BP is equal to mu naught I upon 4 pi r sine theta 1 plus sine theta 2. Mu naught upon 4 pi minus 7. The current is 10 ampere. The perpendicular distance is 0.5. Sine minus 53 plus sine 60. Simplify, it is 20 into 10 ki power minus 7. Right. This is minus sine 53 and this is root 3 by 2. Fine.
Yes.
What is the minus 53? Say 4 by 5 plus root 3 by 2, and this is 20 into 10 ki power minus 7. Right. You may simplify further. So it is 2 into 10 ki power minus 6 minus 8 plus 5 root 3 upon 10. Right. So it is 2 into 5 root 3 minus 8, right, into 10 ki power minus 7 Tesla. This is the magnetic field at point B. Although you can calculate further, but the important thing is that you have to take the theta 1 minus 53 and theta 2 is in the correct direction. All right. Copy this.
Yes.
So read this question. So in this question, the point P is outside line of the wire. Suppose this is the wire and it has the current I in this direction. This is the point P. The point P is this side, and they have given what? They have given this angle alpha 1 and this angle is alpha 2. So you have to find the magnetic field at this point P, and this distance is D. Is it clear or not, you tell?
Yes.
So listen one thing. This is the point A, this is the point B. Right. So they may give, not necessary they give this angle. They may give this angle, right?
Yes.
Suppose this angle is theta 1, right? This angle is theta 2. Is it clear or not?
Yes.
So if you assume the magnetic field is into the board, right? What will be the magnetic field? B is equal to mu naught I upon 4 pi d, d in this case, sine theta 1 plus sine theta 2. Is it clear or not?
Yes.
Listen one thing. If we have found this is B, this is A, and the current is like this. So this is the reference line. The A should be below the line. So it is taken as plus theta 1, right?
Yes.
And the B is taken as plus theta 2 if it is above the line. So the B point is, now if the B reduces, B point angle is reducing like this. So the theta 2 becomes 0 at this point.
Yes.
If we go below the line, then it becomes minus.
Minus.
So if this angle is theta 2, so I have to take minus theta 2 over here. Is it clear or not?
Yes.
So the answer will be mu naught I upon 4 pi d, right? Sine theta 1 minus sine theta 2. Because sine minus theta is minus sine theta, you will remember. But cos minus theta is cos theta, right?
Yes.
Now can you tell me what is the theta 1 angle? Yes, I can tell. In this triangle, listen one thing. Suppose this is the triangle. This is angle alpha 1. This is angle theta 1. What is theta 1? 90 minus alpha 1. So mu naught I upon 4 pi d sine 90 minus alpha 1. Is it clear or not, you tell?
Yes.
What about theta 2? This is the triangle.
Yes.
And this is the triangle. This is theta 2 and this is alpha 2. So theta 2 is what? 90 minus alpha 2.
Yes.
Theta 2 is,
91, sir.
are you getting this thing or not?
Yes, sir.
So mu naught I upon 4 pi d cos alpha 1 minus cos alpha 2. So this is the magnetic field at this point, right into the board. Getting or not?
Yes.
Copy this. So read this question. In this question, right, the magnetic field P due to the both, suppose these are the two wires of the infinite long wire. The current is 5 ampere. The current is 2.5 ampere. The point P is this side, right? This is 2.5 meter. This is 5 meter. Is it clear or not, you tell?
Yes.
You have to find the magnetic field this side. All right. So
Yes.
if these are the infinite wire, so because of this wire, wire 1, the magnetic field is into the board,
Into the board.
and this is the another wire, the magnetic field is into the board. So the total magnetic field at this point will be P1 plus B1 plus B2, right?
Yes.
So I will write, due to first, what is the magnetic field due to this wire? Mu naught I 1 upon 2 pi R1, right? So this is equal to what? 4 pi into 10 ki power minus 7. The current is 5, 2 pi as it is, and the R1 distance is 7.5. Fine. So it is 10 raised to the minus 6 upon 7.5. Are you getting or not?
Yes.
So it may be written as 10 raised to the minus 5 divided by 75, right? And 100 into 10 ki power minus 7 upon 75. So B1 is 4 upon 3 into 10 ki power minus 7 Tesla. Is it clear or not, you tell?
Yes.
The wire 2, mu naught I2 upon 2 pi R2. Is it clear or not, you tell?
Yes, sir.
4 pi into 10 ki power minus 7. The I2 is what? 2.5, 2 pi into, what is R2 here? Tell me.
That is 2.5.
2.5. It will cancel out. So it is 2 into 10 ki power minus 7 Tesla. This is into the board. This is also into the board. So what is the total magnetic field at this point P? B1 plus B2. 4 by 3 minus 7 plus 2 into 10 की पावर minus 7. So 3 दूनी 6 और 4, 10 upon 3 into 10 की पावर minus 7 into the board, right?
Yes.
Okay, but the answer is not in this form, right? So listen, the B1 plus B2 is equal to mu naught upon 2 pi I1 upon R1 plus I2 upon R2, right? Mu naught upon 4 pi, 2 pi. I1 is 5, R1 is 7.5, I2 is 2.5 and 2.5. So mu naught upon 2 pi, right? Simplify. This is 2 by 3 plus 1. Mu naught upon 2 pi, 5 by 3. So it is 5 mu naught upon 6 pi. So this is the magnetic field at the point B. This is into the board, right? So the second option is the correct option. Copy this. So read this question, right? You have to find magnetic field at a point P due to the current distribution. This is the infinite wire. This is the another infinite wire. The current is I. At this point P, which is that distance R from the origin, suppose this angle is 45. You have to find the magnetic field at this point. All right. So first take, this is the first portion, right? You forget for this, and because of this first portion, suppose this is the perpendicular distance D, you may assume this is the point A, and the B point is what? Say infinity.
Yes.
So for this portion, the theta 2 become what? 90, and if it was 45, it was 45. So the theta 1 become 45. So because of this first portion, the magnetic field is into the board. So the B1 may be written as mu naught I upon 4 pi d sine 45 plus sine 90. Is it clear or not, you tell?
Yes.
Right. So also this distance r is known, not this distance d. We have to take this perpendicular distance, not this distance. So the cos 45, if you apply, cos 45 is base upon hypotenuse. In this triangle, base upon hypotenuse. 1 by root 2 is equal to d upon r by root 2, equal to mu naught I upon 4 pi, r upon root 2, 1 by root 2 plus 1. So mu naught I upon 4 pi r root 2, simplify upon root 2, will cancel out mu naught I upon 4 pi root 2 plus 1. This is the B1 into the board. Is it clear or not?
Yes.
So this is due to the first portion. Now I consider, right, this is the second portion, right? If you consider this is the second portion, right, and this is the second portion, this is the current, this is the distance d, this is the A, you have to find the magnetic field at this point, right? It is into the board. Fine. So if you consider this is the reference line, this angle is supposed to be theta 1 and this angle is supposed to be theta 2. So this is the B point, suppose, and it is going to infinity, it means the angle become theta 2 90 degree. Fine. And this angle become 45 because it is 45. This angle is 45. So this angle is, right, this is the reference line, this angle is 45. So theta 1 45, theta 2 45. The magnetic field B2 will be calculated in the same way. So B2 is also equal to what? B1, and it is into the board. Into the board, and the magnetic field due to this portion is also into the board. Into the board, into the board. Both have the same magnitude. So what is the total magnetic field? 2 times of this. Mu naught I upon 4 pi r root 2 plus 1. Root 2 plus 1 into the board. Is it clear or not, you tell?
Yes.
So the fourth option is the correct option. Copy this. So read this question. In this question, write magnetic field at origin O due to the current distribution. Suppose this is the x-axis, this is the y-axis. The current is coming from the x-axis like this, right, and it is going in this way. This is the I. In the y-axis, current is coming from infinity and going in this direction. Is it clear or not, you tell?
Yes.
You have to find the magnetic field at this point. All right.
Yes.
This is the I. Fine.
Yes.
Right? This is the I and this is the O. Listen, one more thing. One important point I am telling you, if you don't notice that, if this is the current carrying wire and the point P lies on the wire at this point or this side, any point P lies in the line of the wire, the magnetic field at this point will be 0. Is it clear or not?
Yes.
Why it is 0? देखो, if this is the theta, mu naught I upon 4 pi r, right? Mu naught I dl sin theta. Is it clear or not?
Yes.
R square sin theta. So B proportional to what? Say sin theta.
Sine.
The angle between dl vector and r vector.
Yes.
If this point shift to this point, the theta be reducing,
0. Yes.
theta reducing, and in this case, when the point be like this, so theta become 0.
Yes.
Although due to this dl, everything is there, I there, dl there, but r also there, but theta become 0.
0.
In the same way, if this point to come here, so this angle become what? At this point, 180 degree.
Yes.
This is reducing, this is increasing. So this dl vector, this angle is theta is increasing 180. So sine 180 is also 0. So therefore, if a point lies on the line of wire, B at that point, due to that wire will be 0. All right,
Yes.
copy this. So now we can do this question. This question has the 2 wires, so I will divide. This is the 1 wire from infinity to this point. We have to find the magnetic field at this point. Suppose this is the one part, minus infinity to A. So due to this wire portion, the magnetic field at this point will be 0,
0.
because this point lies on the line of this wire. So B1 due to this portion at this point O is 0 or not, you tell.
Yes.
Now the second part is this. This is the infinite wire, semi-infinite wire. It is what? Semi-infinite wire, right?
Yes.
So this is the current carrying wire direction. The magnetic field will be out of the board.
Yes.
What is the magnetic field B2? Due to semi-infinite wire, mu naught I upon 4 pi d. It is out of the board. Is it clear or not?
Yes.
Now, if you consider this the third portion, the point O lies on the line of the wire. So due to third portion, the magnetic field is 0. And now this is the fourth portion, this semi-infinite, right? Semi-infinite. So what is the direction? The wire is in this direction, out, right? This side into this side, out. So the B4 is semi-infinite wire, 4 pi d, out. This is also out, this is also out, this is also out. So due to third and the first, 0, due to second, out, due to fourth, out. So what is the net magnetic field? B1, B2, B3, B4. 0, it is out, it is also out, right?
Yes.
So if you add them, 2 pi d, and this is out of the board.
Yes.
All right, copy this. So read this question. In this question, the different polygons are given. Suppose you consider first the equilateral triangle, right? And the current carrying wire is I, and you can assume the side of the wire is to be A. All right, and you have to find the magnetic field at the center, right? So if you consider this is the portion wire AB, right? So if you consider this is the perpendicular distance, This is the equilateral triangle, it is 30 degree or not, you tell. So this angle is 60 degree, this angle is 60 degree. If due to this portion, suppose this is the portion A, this is the point B, and you have to find the magnetic field at this point. So this is the reference line. So the A angle, this angle is what? Say theta 1, which is equal to 60 degree, and this reference line, this is the point B. In this direction from reference line, theta 2 is 60 degree. Is it clear or not?
Yes.
The current carrying wire is in this, current is in this direction. So current is towards left, the magnetic field will be into the paper, into the board. Suppose this is the R. So the B1, suppose this is the portion 1 is mu naught I upon 4 pi R sine theta 1 sine theta 2. 60 plus 60. Is it clear or not? This R we have to find because we know the side of the wire. This distance is what? A by 2. So now the tan 30 in this triangle perpendicular upon base. 1 by root 3 is equal to R upon A by 2, A upon 2 root 3. Is it clear or not? So this is equal to mu naught I upon 4 pi A upon 2 root 3 sine 60 root 3 by 2 plus root 3 by 2. It become root 3. Is it clear or not? If you simplify, it become 3 mu naught I, root 3 into root 3, 2 will cancel out, 2 pi A. Alright. So this is the magnetic field due to the one part only. It is into the board. But if you consider the magnetic field due to the BC part, right, you will see this thing is similar, right? This is 60 degree, this is also 60 degree, this is the distance T, R. Are you getting or not? So due to this portion, magnetic field into the board, due to this portion into the board, due to this portion into the board. So at the center, the total magnetic field will be 3 times of, right? This is the 2, 3, and I am writing B1 plus B2 plus B3, but both are same, B plus B plus B. It is equal to 3B. And what is the B we have found? 3 by 2 mu naught I upon pi A. So the 9 by 2 mu naught I upon pi A. This is the magnetic field at the center, right? So which option is the correct option, you tell? The third option is the correct option. Fine, copy this. So now we discuss the magnetic field due to the regular polygon of n side. Consider the polygon of n side, right? And side length is what? A, right? A. It may be the triangle, it may be the square, it may be the hexagon or heptagon, right? The polygon mean, suppose this is the polygon. Are you getting or not? And the side of the polygon is what? A. And the current is flowing I over here. Is it clear or not? So at the center you have to find the magnetic field. All right, right? You consider this is the one portion AB. Consider the AB portion, right? Due to the AB portion, the magnetic field at the center will be into the board or not, you tell? If this is the perpendicular distance, all right. Tell me, what is this angle? What is this angle? The total angle is what? What is the total angle? Say 2 pi. And how many sides are there? 1, 2, 3, n. So this angle will be equal to 2 pi by n. Is it clear or not?
Yes.
Right. So if you consider this is the perpendicular bisector, so this half angle will be pi by n and this half angle will be pi by n. Is it clear or not?
Yes.
And suppose this perpendicular distance is r and this is what? Say a by 2. So we have to find also this perpendicular distance r. So tan pi by n is equal to perpendicular upon base a by 2 upon r, right? So is equal to a upon 2r. This is tan pi by n. So r is equal to a upon 2 tan pi by n. So this is the perpendicular distance from the length wire AB. All right.
Yes.
And what is the theta 1 and theta 2? Here the theta 1 and theta 2 both are equal, is equal to pi by n. So due to wire AB, the current supposed to be I. So what is the magnetic field? B is equal to B1 is equal to B1 due to this one portion mu naught I upon 4 pi r sine theta 1 plus sine theta 2. Is it clear?
Yes.
So this is mu naught I upon 4 pi I. What is r? It is a upon 2 tan pi by n, right? And sine pi by n plus sine pi by n. Is it clear or not, you tell?
Yes.
You may simplify it further. This is mu naught I upon 4 pi a, right? It goes in numerator 2 tan pi by n and it become 2 sine, right? This is equal to 2 tan 2 sine pi by n. Is it clear or not, you tell?
Yes.
So 2 and 2 will cancel out, right? So what is the net magnetic field, you tell? 2 2 is 4. B is equal to what? Mu naught I upon pi a into tan pi by n into sine pi by n, right?
Yes.
This is the magnetic field due to one portion. How many portions or how many wires are there? N. So the total magnetic field at the center, the total magnetic field is n times of B1. That is n mu naught I upon pi a into tan pi by n into sine pi by n. Is it clear or not, you tell? Right. So this formula you will remember, n mu naught I upon pi a tan pi by n sine pi by n. Is it clear or not?
Yes.
For example, for equilateral triangle, right, of side length a, n will be equal to what? Say 3, because this is for every type of the polygon. If n is equal to 3, the total magnetic field at the center, right, will be into the board 3 mu naught I upon pi a tan pi by 3, right, and sine pi by 3. Is it clear?
Yes.
Tan pi by 3 is tan 60, it is root 3, sine 60 is root 3 by 2. This is 3 mu naught I upon pi a. Root 3, it will be 9 by 2 mu naught I upon pi a. So yesterday we have found, right, in the previous lecture we have found 9 by 2 mu naught I upon pi a. Is it clear or not due to triangle?
Yes.
Copy this.
Done, sir.
Right?
Yes.
Very good, very good. Okay, so this is the formula for the regular polygon, right? For example, if you want to find the square for square, if this is the square and you want to write the magnetic field at the center, so no need to do all the derivation, rather Just you remember this formula, and n is equal to 4. So at the center, the magnetic field, the side of the square is supposed to be A, 4 mu naught I upon pi A, right?
Yes.
And tan pi by 4 sine pi by 4. So it is 4 mu naught I upon pi A. This is tan 45 sine 45. So mu naught I upon pi A, right? And this is 2 root 2. This is the total magnetic field at the center. For hexagon, tell me, the value of n is equal to what? 6. And I think you will remember the formula, n mu naught I upon pi A, tan multiply by sine, right? So 6 mu naught I upon pi A, tan pi by 6 sine pi by 6. Is it clear?
Yes.
Upon pi A, tan 30 sine 30 1 by 2. Are you getting or not? So it will be equal to root 3 mu naught upon pi A. So you can write the total magnetic field using this formula. For hexagon, suppose this is the hexagon, right? Like this. The current is I. So at the center of the hexagon, the magnetic field will be into the board, and its value, right, will be this. Copy this. So in this question, read this question. A square loop of side A is made by this is the square loop, suppose, right? And the current carrying wire is like this, all right? And here we have to find the magnetic field. Are you getting or not? You tell. This is the side A. The magnetic field we have to find. So how many portions are there? 1, 2, 3, 4. Is it clear or not? So due to this one portion, right, because P lies on the line of this wire, so because of this, the magnetic field at the point P will be 0. Also due to this wire, it lies on the line of the wire, so the B4 is equal to what? 0. Are you getting or not? Only the magnetic field will be due to the second wire. Suppose this is the current I, right, and this is the point P. So you have to find, suppose this is the AB, this is the reference line. What is the perpendicular distance? Say A. So the B is making angle. I think you understand this angle is what? 45. And what is this is the angle theta 2, and what is the angle theta 1? 0. If the wire was in this side, the point was A, so it will be theta 1 and it will be theta 2. But this point A start from here, so the theta 1 value is what? 0, and this is the theta 2 value. Is it clear or not?
Yes.
So the magnetic field is out of the board. So the B due to wire 2, mu naught I upon 4 pi R, the value of R is A sine theta 1 plus sine theta 2. It is sine 0, it is sine 45, right? Sine 0 is 1 and it is 1 by root 2. Are you getting or not? You tell. So therefore, the B2, because of this part, mu naught I upon 4 pi A into 1 upon root 2. Is it clear or not?
Yes.
Now we consider the third part. If you consider this is the third part, the current is I, this is the point P, right? And suppose this is the B, this is the C. So this is the finite wire. This is the perpendicular distance, again A. This is the reference line. So from reference line, this angle is 45. You may consider this the theta 1, and this point lies at this point. So what is the theta 2 value? It is 0 again. So the magnetic field will be out of the board, right? So if this portion is third portion, B3 is what? Same, mu naught I upon 4 pi A, right? Sine 45 plus sine 0, right? The same calculation we have to do, and we will get the same answer, mu naught I upon 4 pi 1 by root 2. It is out of the board, and this magnetic field is out of the board. So due to all portion 0 plus 0, B2 plus B3. So the B at point P, B1 plus B2 plus B3 plus B4. This value is 0, this value is 0. B2 and B1 both are out of the board. If you take this the positive, then it is also positive. So add them. Mu naught I upon 4 pi a, right, root 2 plus mu naught I upon 4 pi a, root 2. So the answer will be mu naught I upon 2 pi a, root 2, because it is multiplied by 2, right, and the answer, final answer will be pi a root 2. So BP is equal to what? Mu naught I upon pi a root 2 out of the board, right? Copy this. So read this question. In this question, two long parallel wire, right, this is the long wire, carries the current in the same direction I and 2I, right, just between, magnetic field just between the wire is suppose B, right. Suppose this is the distance A, this is the distance A. Are you getting or not? Right, you may assume this is the I and I, so it will be, it looks good. So because of this wire, the magnetic field is into the board, and because of this wire, out of the board. And due to infinite wire, this is the wire 1, the B1 will be equal to mu naught I upon 2 pi a. Mu naught I upon 2 pi a, the value of I is 2I, and this is into the board. Because of the second wire, the magnetic field is mu naught I upon 2 pi a, say out of the board. Is it clear or not, you tell? So at this point, the magnetic field given in the question is B. So if you consider this the positive, so if it is into the board positive you are taking, so out of the board will be negative, right? So what is that? If you consider this the point P is equal to what? B1, right, minus B2. B1 is what? 2 mu naught I upon 2 pi a minus mu naught I upon 2 pi a. So what is the it is mu naught I upon 2 pi a. It is given in the question that this magnetic field is B. Are you getting or not? You tell.
Yes.
Now 2I current is switch off. If it is switch off, only the current I remains at distance A at the point P. Tell me, the magnetic field will be out of the board due to this wire. B dash will be equal to mu naught I upon 2 pi a, and its value we have found equal to B. Now the magnetic field is B, right? So which option is the correct option, you tell? The second option, right? Copy this. So read this question, right? In this illustration, two infinite length wires. This is the one wire along the x-axis. This is the another wire along the y-axis, right? These are the 4 point A, B, C and D, right? So they are asking on which point the magnetic field will be 0, right? So how to find that? It is the current I, it is the current I along the x-axis, along the y-axis. Are you getting or not? So if you consider the point A, because of this wire, the magnetic field is out of the board, and because of this wire, the magnetic field is out, right, into the board. So if you take into the board is positive and out of the board is negative, so the total magnetic field is 0. Out will cancel with in. So at this point, the magnetic field is what? 0. But if you consider this point, this is the current carrying wire, the magnetic field is out, and this is the current carrying wire, magnetic field is out. So if you consider the out to be B and B, so at the point BB, the magnetic field is 2BB and it is not equal to 0. Understood? Now if you consider the C point, because of this wire, the magnetic field is what? Into the board? Into. And because of this wire?
Out.
Out. So because of this into and because of this out, so the BC is at 0. So the point A and point C are the correct point. Let me check at D. Because of this wire,
Yes.
magnetic field is
Into.
into. And because of this wire, it is
Into.
into. So B plus B, it may be 2B. So what are the points? At points A and C, the net magnetic field is 0. Copy this. So read this question. In this illustration, for given current distribution, each infinite length wire produce magnetic field B at wire. For example, if this is the x-axis, y-axis, if you consider this is the current carrying wire and the current is what? Into the board, right? If this is taken to the into the board like this, right? So what is the direction of the magnetic field at this point?
Yes.
Upward. Are you getting? Because of this current carrying wire into the board, magnetic field will be like this, like this, like this. Are you getting or not? So at this, due to this, the upward direction. And in the question it is said that the magnetic field is B due to the infinite wire. So if you consider this wire, the magnetic field because of this wire is B in this direction. Is it clear or not, you tell?
Yes.
Another wire is also there, but it is dot and it is cross. So if this is also cross, the magnetic field will be in this direction, right?
Yes.
The magnetic field will be in this direction at this point, like this. Is it clear or not, you tell?
Yes, sir.
And because of this dot, the current I is out of the board.
Yes.
So if it out of the board, the magnetic field due to this out of the board current, it is the magnetic field. It is the magnetic field. Are you getting or not?
Yes.
The magnetic field is like this. So towards right side of this, the magnetic field will be in this direction. All right. And because of this wire, the magnetic field in this direction, right?
Yes.
So this is the P. So because of this wire, the magnetic field is like this. So the 2B is this side, 2B is this side. So what is the resultant magnetic field? 2B root 2 in this direction. 2B root 2. Are you getting this solution or not? Copy this. So read this question. So in this question there are two parts and you have to find the position of the point from wire B where the net magnetic field is 0. In the part A, this is the wire 1, wire A, this is the wire B, right? And the 5 ampere current and the 2 ampere current is flowing and the separation between them is 6 centimeter. Is it clear or not?
Yes.
So listen one thing. Suppose from the wire B, right, the distance is x. Because of this wire, the wire is outside, the magnetic field is in this direction, into the downward, right? Downward. So this is the VB, right? You assumed it is to be I1, so I am writing the I1. It is to be I2 because this is also outside. So what is the direction of magnetic field? Upwards. This is the B2, right? This is 6 minus x. So what is the B1 value? Due to infinite wire, mu naught I1 upon 2 pi x. What is the B2 value? Mu naught I2 upon 2 pi 6 minus x. I am writing in centimeter only. So if the net magnetic field at this point P is 0, then V1 and V2 must be equal and opposite, right? So now the B1 is mu naught I1 2 pi x, mu naught I2 2 pi 6 minus x. I1 upon x is equal to I2 upon I1 is 2i 5i, right?
Yes.
So 2 6 minus x is equal to 5x. 12 minus 2x is equal to 5x. Fine. 12 is equal to 7x. X is equal to 12 upon 7 centimeter. From wire B, at this distance, the net magnetic field is 0, right? Copy this. So now you can read the B part. In the B part, what is given? Tell me. It is 5i and it is 2i in the downward direction into the board, right? The distance is 6 centimeter, right? If you want to find the position where the net magnetic field is 0, if you choose any point, because of this wire, the magnetic field is, suppose is I1, the B1 in this direction, and because of this wire, right,
It is also upward.
it is also upward. Very good. So it is not possible to have any position of point P between A and B so that net magnetic field is 0. So the position of the point will be, right, suppose this is the A, this is the B, 2i, and this is 5i, this is 2i. The position will be towards the left, towards the right of the wire B at distance x. Why it is so? Listen one thing. Because of this wire, right, suppose this is the I2, the magnetic field is downward, and because of this, the magnetic field is upward. And this distance is 6 plus x, right, and this distance is x. This current is low, this current is small, distance is also small. This current, this value is big, and the current is also big. So therefore the magnetic field may be 0 this side, such that B1 and B2 we have to put equal. Suppose this is the I2, mu naught I2 upon 2 pi x. The B1, because of this current I1, mu naught I1 upon 2 pi 6 plus x. So B1 and B2 both are equal and opposite direction. Fine.
Yes.
2 pi x. It will cancel out. I1 is what? 5i 6 plus x. I2 is what? 2i upon x. Is it clear or not? You tell. I will also cancel out. It is 5x is equal to 12 plus 2x is equal to what? 3x plus 12. X is equal to 4 centimeter. Right. So the first option is the correct option. Right. And from here B towards the right, 4 centimeter is the position where the net magnetic field is 0.